Hello everyone! I hope you are fine and safe. Welcome to our second online lab class. Today I will talk about two important soil properties, soil bulk density and total porosity. And let's go! I hope you enjoy. Okay, you can see here the soil water air relationship. And normally in natural conditions the soil is composed by 50% of soil particles, including soil minerals and soil organic matter, and 50% correspond to soil pores. Okay, maybe air and water, um, only water and only air, for example. Normally, the mass of soil is expressed in grams and the soil volume is expressed in cubic centimeter. Okay, and now please look at this scheme and look to the left side, and you have here the V. The V is the soil bulk volume in cubic centimeter, and F the total porosity. The total porosity is equal to VA plus VW. Okay, VA is the volume of air, VW is the volume of water. Okay, go ahead, and VS is the volume of solids, soil particles, soil minerals plus organic matter. Okay, and now look to the right side. We have the MA is the mass of air. It can be considered 0. And again, MW and now is the mass of water. And MS is the mass of soil. And MT is the total mass of soil. MA plus MW plus MS. Okay? This is the soil water air relationship. Okay? Okay guys, as you know, again, the soil bulk density is the ratio between MS. MS means the mass of soil, soil minerals and organic matter, divided by V. V is the volume, the soil bulk volume, right? And soil particle density is the ratio between MS divided by Vs, not V. Vs is the volume of soil. Okay, pay attention, it's different. All right, let's go. Okay, my first questions for you all is, why is determination of soil bulk density and total porosity important? And these are two important soil properties, and normally the soil bulk density ranges from, for example, 0.3 for organic rich soils, peaty soils, to 1.9 grams per cubic centimeter for compacted soils, for instance. And total porosity ranges from 30 or less to 60%, right? And of course, as the soil bulk density increases, the total porosity decreases, okay? And there are many soil properties and processes occur in the soil and influenced by soil bulk density and total porosity. For example, soil aeration, water infiltration and permeability, root growth, and soil biota, and among others. And also the soil bulk density and total porosity are naturally influenced, for example, by soil texture. As you know, we have soils with different soil texture, clay soils, sandy soils, all right, remember? And also we have and soils with different soil structure, granular structure, block structure, okay, and soil organic matter, and some soils impacted by compaction. Okay, that's it. Let's go. Okay, my second question is how can we measure the soil bulk density and total porosity? Okay, basically we have destructive methods and non-destructive methods. Okay, um, the first one, destructive methods, um, are easy, cheap, but I have to collect in the field undisturbed soil samples. Okay, and for example, we have the volumetric cylinder method. I had plans to collect undisturbed soil samples in the field for to gather you all, but unfortunately it's impossible now. Okay, we have non-destructive methods, and they are more sophisticated. Sometimes for more detailed studies I can use undisturbed soil samples, or I can measure directly in the field. For example, X-ray tomography and neutron and gamma probes. Okay, this is a very interesting paper published in 2018, and I strongly recommend this paper for you all. You can find all information about soil bulk density determination, and also the main soil properties and or factors influence the soil bulk density are discussed. Okay, you can download it using the link below. Okay, here you can see some pictures of volumetric cylinder method, and basically I need a volumetric cylinder, maybe aluminum cylinder, and for example 5 centimeters diameter and 5 centimeter high. Okay, maybe. And I need a sampler. Okay, as you can see in figure A, I can use a different cylinder size, but I need the proper sampler. Sometimes this sampler is known as Uland sampler type, right? And the sampler will help you to insert the cylinder into the soil, as you can see in figure B. After you insert the cylinder into the soil, you must remove the soil surround and collect the cylinder and bring to the lab. Okay? In figure C, you can see undisturbed soil samples. Okay? Okay, finally, to determine the soil bulk density, you need the MS, remember? The mass of soil, and V, the soil bulk volume, okay? The soil bulk volume is equal to cylinder volume. You can easily determine the cylinder volume, okay? After that, oven dry the samples in using an oven, and after 24 hours, 48 hours, until dry the samples totally, right? And you must record the mass of oven dry soils plus cylinder. Okay, since you know the mass of cylinder, by difference you can get the oven dry soil. Okay, you have all information you need to determine the soil bulk density. Okay, MS divided by V. Okay, that's it. Easy. Okay, and now, how can I determine the total porosity? I have two options, calculated option and determined option. Okay, the first one, it's very easy. Okay, since I know the soil bulk density, for example, 1.2, and I know the soil particle density, remember, I can measure or I can consider 2.65. Do you remember why? Okay, let's go. The total porosity is equal to 1 minus the soil bulk density divided by soil particle density. 1 minus 1.2 divided by 2.65. Okay, as a result, I have 0.55 cubic centimeter by cubic centimeter, or in other words, 55%. What means 55% of total volume? And if you imagine your volumetric cylinder, 55 correspond to soil pores. The soil pores may contain only water, saturated condition, water plus air, or only air, the dry conditions, right? And 45%, of course, the soil particles. Okay? And the second option, under lab conditions, it's possible to determine the total porosity. How? I can determine the total porosity based on the amount, the volume of water required to fill all soil pores. Does this make sense? Okay, I have two options. Calculated, I need the soil bulk density and soil particle density. Okay, and the term option, I have to determine the volume of water I need to fill all soil pore network. All right, that's it. Okay, guys, look at this picture and think about. And if you consider the soil bulk volume, okay, the V, like a box, like a cube. For example, box 1 or cube 1 and box 2 or cube 2. Okay? And look the box 1 or cube 1. It contains a smaller soil aggregate. Okay? The soil aggregates may be the red balls, like a spheres. Okay? And the soil pores are smaller than box 2, the cube 2. But the total porosity of box 1 and box 2 is the same. Okay? The total porosity is important, but it's also important to know the soil size pore distribution. Basically, soil pores bigger than 0.08 millimeters are considered macropores. The macropores are responsible for soil aeration and drainage, and the soil pores smaller than 0.08 millimeters are considered micropores, and the micropores are responsible for soil water retention. Okay, it's very important. Total porosity and the soil pore size distribution. And now look this picture This is a very interesting scheme. You can see here a more detailed soil pore size distribution. For example, macropores, mesopores, micropores, ultramicropores, and also you have the information about drainable pores, storage pores, residual pores, and also according to the soil pore size distribution, and you can find some information about the nematodes, occurrence, roots, bacteria occurring in the soil according to the soil pores, and also what else? The virals. Okay, it's a very interesting picture scheme, and to understand the importance of course, the soil pores, the total porosity, and also the soil pore size distribution. Okay, it's very important. Okay, guys, that's enough for today. I hope you enjoyed. And here you can find some additional links. I select a YouTube movie to show you the sampling procedure of undisturbed soil samples. And of course, some modifications and variations are perfectly expected. Okay, this is just for you get the idea about, right? And also I'm sending you by mail two materials from Encyclopedia of Soil Science about soil bulk density and soil porosity. All right, and take care. Have a nice week and see you. Bye bye.